Welcome to our exploration of one of chemistry's greatest achievements, the periodic table. This remarkable tool organizes all known elements in a way that reveals the fundamental patterns of matter. At its heart lies the visionary work of Dmitri Mendeleev, whose brilliant insight transformed chemistry from a collection of scattered facts into an organized science. Imagine being a chemist in the 1860s. You know about 63 different elements, each with unique properties. Some are metals, some are gases, some react violently with water while others don't react at all. The challenge facing scientists was enormous. How do you make sense of this bewildering diversity? How do you find order in what appears to be chaos? Scientists tried various approaches to organize the elements. Some arranged them by atomic mass, simply listing elements from lightest to heaviest. Others grouped elements by their chemical properties, putting reactive metals together or noble gases in one category. A third approach divided elements into broad categories like metals versus nonmetals. While each method revealed something useful, none captured the complete picture. In 1869, a Russian chemist named Dmitri Mendeleev was preparing a textbook and wrestling with how to present the elements to his students. His struggle led to one of science's greatest breakthroughs. Mendeleev brought a unique combination of chemical knowledge, pattern recognition, and bold thinking to this challenge. Mendeleev's crucial discovery was this: when you arrange elements in order of increasing atomic mass, their chemical and physical properties repeat in a periodic pattern. Similar elements appear at regular intervals. This periodicity meant that chemistry wasn't random. There was an underlying order, a rhythm to how elements behave. This insight became known as the periodic law. Mendeleev organized his table using two principles. First, arrange elements in rows, called periods, by increasing atomic mass. Second, start a new row whenever necessary so that elements with similar properties line up in vertical columns, called groups. This two-dimensional arrangement revealed relationships that had been invisible before. Here's where Mendeleev showed true scientific courage. When the pattern demanded it, he left empty spaces in his table. Rather than seeing these gaps as failures, he declared they represented elements that hadn't been discovered yet. He was so confident in his periodic law that he predicted these unknown elements would eventually be found. Mendeleev's predictions were spectacularly confirmed. He called his predicted elements by temporary names: ekaluminum, ekaboron, and ekasilicon. Gallium was discovered in 1875, matching his ekaluminum prediction. Scandium followed in 1879 as ekaboron. Finally, germanium was found in 1886, fulfilling the ekasilicon prediction. The properties of all three matched Mendeleev's predictions with stunning accuracy. The periodic table revolutionized chemistry in two fundamental ways. First, it gave scientists predictive power. They could now anticipate properties of unknown elements and know where to search for them. Second, it revealed that atomic structure wasn't random. The periodic patterns hinted at deeper rules governing how atoms are built, paving the way for 20th century discoveries about electrons and quantum mechanics. Mendeleev's periodic table transformed chemistry from a chaotic collection of facts into an organized, predictive science. Today, the table has been refined and expanded to include over 118 elements, but its fundamental logic remains Mendeleev's. Every chemistry student, researcher, and educator relies on this tool daily. It stands as a testament to the power of seeking patterns and having the courage to trust them.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.